Hey guys, it's Miss Russell. I am here to help you with Day 16 AMI lesson. So before we read the passage, I want to take a look at the question so we know what sort of information we need to look for as we're reading through the passage. So question number 1 says, how many stations recorded ozone data in 2006? So the two key words in here are stations and 2006. So we need to look for these two particular pieces of information as we read the passage. Question number 2 was kind of long and a little tricky, so I broke it down. They're really asking two different things, so I broke it down into parts. Part 1 says, using the data given in graph 4.4 and image 4.6, explain what has been the trend or the pattern of the presence of ozone in the atmosphere. And I highlighted atmosphere because when we read the passage, there are two different places where they took ozone readings. And this question only wants us to look at the atmosphere. And then part 2 says, describe how the image may appear today. So they've given us a graph 4.4 and an image 4.6. So the second part of question 2 wants us to take the information from both of these, this graph and this image, and see if we can figure out, based on the data and the information that they give us, what does it look like in our atmosphere today, 2020. So now let's read the passage. It says, ozone is a gas made up of 3 oxygen atoms, or O3. It occurs naturally in small trace amounts in the upper atmosphere, called the stratosphere. In the troposphere, near the Earth's surface, ozone is created by chemical reactions between air pollutants from vehicle exhaust, gasoline vapors, and other emissions. Emissions are things that are released from an object. At ground level, high concentrations of ozone can be toxic or poison to people and plants, and is a main ingredient in urban smog. Smog is if you're in a city and sometimes because of the pollution and the trash in the air, it makes the air look a little milky or fuzzy. That's from smog, or that is called smog. Without ozone, intense UV or ultraviolet radiation would end life on Earth's surface. Ozone is destroyed when it reacts with molecules containing nitrogen, hydrogen, chlorine, or bromine. And here, reacts means to mix with. Some of the molecules that destroy ozone occur naturally, but people have created others. The term ozone depletion means that ozone loss is exceeded or greater than ozone creation. In 1956, the British Antarctic Survey set up the Haley Bay Observatory on Antarctica and began ozone measurements using a Dobson spectrophotometer. And then I took the pieces and parts of that word and broke it down, because remember, that's what we've talked about doing. If you see a massively huge word, break it down into pieces and parts and see if you can figure out what it means. So spectro means to watch or to see. When you see photo, that means light. And meter in this case means it's an instrument that's used to measure. The graph below depicts recorded ozone over the last 50 years. Instruments on the ground at Haley and high above Antarctica, the Total Ozone Mapping Spectrometer, or TOMS, and Ozone Monitoring Instrument, or OMI, measured total atmospheric ozone. So this might be a hint, because remember, the two questions ask us about atmosphere, and here's the word atmospheric ozone. The data that has been collected over the last 50 plus years is graphed here. So question number 1 again says, how many stations recorded ozone data in 2006? So I don't remember seeing anything about 2006 in here in the reading passage. So that tells me that I want to check the graph and the image. So in the graph, I look along the x-axis and I see years, 1960, 1970, 1980. So the x-axis on graph 4.4 is measuring in decades, and a decade is a measurement of 10 years. So this goes down to 2000, so you would have to count which one of these smaller lines would equal 2006, and then go back into the reading passage and see which one would be a station. Now remember, there's lots of information in this passage. Some of them are stations and some of them are actual instruments. So double check that you're really looking for the correct information that the question's asking you for. The sentence frame that you might want to use is blank stations located at blank recorded ozone data in 2006. I added located at in the sentence frame just to help you zero in on the right information that the question is really asking for. Because remember, it's asking for stations, and in the passage it talks about stations and instruments. So be careful what information you give for this question. Question 2 says, using the data given in graph 4.4 and image 4.6, explain what has been the trend or the pattern of the presence of ozone in the atmosphere. So remember, you have to look over here. Is the Haley, was that in the atmosphere or was that on the ground? And Haley, it's in red, so that means that all these red dots are telling you about Haley. Tom's, since it's in green, all the green dots are for Tom. And you'll have to look back in the passage. Is that on the ground or was that in the atmosphere? And then the third thing, which only has 2 data points, is OMI. So again, you're going to have to go back up and look. Was the OMI on the ground or in the atmosphere? And then part 2 says, describe how the image may appear today. So if it were me, I would look at graph 4.4 and image 4.6 and look at what information both are giving me, and then sort of marry those two together and see if I can see a trend or a pattern, and then see if I can decide what might be happening in 2020. And remember, this doesn't go all the way out to 2020. This graph goes to maybe 2009, 2010, and this image only tells us about 1983 to 1993. So you're going to have to give it some thought and see, based on what these two pieces of information are giving you, what can you decide, or what do you think, hypothesize, might be happening now? And the sentence frame for this question is based on the data, the graph 4.4 and image 4.6, the presence of ozone in the atmosphere has what? What's happened to the ozone? And one thing we didn't talk about in image 4.6, if you look down at the bottom, Dobson units is the unit of measure for the amount of ozone in the atmosphere. As you go darker, remember, if you'll notice, the number's getting smaller. So the darker the image, the less ozone there is. The higher the number, or the lighter the image, the more ozone there is. So this Dobson unit goes from 100 to 450. So make sure that you're interpreting the data or the image in the right way. And then another sentence frame for question 2, in both 4.4, in both graph 4.4 and image 4.6, the data shows what? What can you tell me when you take all of this information these two are giving me? If the image appeared today, it would what? Do you think the ozone would be the same? Do you think it would be less? Do you think there would be no change? So remember, it's only asking you to use the information that you've been given here. If you see a pattern or a trend between these two, what do you think might be happening now? And remember, if you have any questions or this is all still a little fuzzy, you can reach out to any of your teachers. We all have access, even the 9th grade teachers. So if you reach out to whoever you think might be able to help you. I hope you're having a great Monday. Enjoy your day, and I'll talk to you later. Bye.